Okay, we want to use the trapezoid rule to approximate an integral. Here we're going to use the trapezoid with n equals 4. Recall the trapezoid by the trapezoid rule. Area is approximated by b minus a over 2n times f of x0 plus twice f of x1 twice f of x2, and so on all the way down to f of xn. So the first thing we do is, just like we did with our rectangles, is we start with a partition. Well, delta x would be b minus a over n, so 4 minus 4 over 1. So our partition would look like this. x0 equals 0, x1 equals 1, x2 equals 2, x3 equals 3, x4 equals 4. So to approximate our area, we're now going to use our function f of x, and we just plug that information into our trapezoid rule. So area would be approximately b minus a over 2n so we would do f of 0 plus twice f of 1 plus twice f of 2. Right, all the middle guys get twice. F of 3 twice f of 3 plus f of 4. Now it's just a matter of plugging all that stuff in. So 4 minus 0 would be 4 over 8 would be 1/2. F of 0 is 0. F of 1 is 1 times 2 would be 2. F of 2, 2 squared times 2 would be 8. F of 3 would be 9 times 2 would be 18. F of 4 would be 16. And it's just a matter of working that out and adding everything up on the inside. If 10 plus 34 would be 44. Half of 44 is 22. So we get an approximate area of 22, and you can then compare that to the area, the actual area, which was 64/3 or 21 1/3. So we're a little bit over the actual area. Now in our second example with the trapezoid rule, we want to approximate the integral from 0 to 1 of e to the negative x squared over 2 dx. Okay, now this is actually one that we cannot find an antiderivative for. Try as you might, you will not find an antiderivative for e to the negative x squared over 2. So we have to use an approximation method. So here our interval, our number of trapezoids we want to use is 6. So again, we would start by figuring out our delta x. Be 1 minus 0 over 6. Be 1/6. Okay, and then we take those. That'll lead us to our partition values of 0, 1/6, 1/3, 1/2, 2/3, 5 over 6, and 1. So we then just want to set up our partition, or set up our trapezoid now. Area is approximately b minus a over 2n, and then we'd have f of 0 plus 2 times f of 1, or not 1, but 1/6, sorry, plus 2 times f of 1/3 plus 2 times f of a half plus 2 times f of 2/3 plus 2 times f of 5/6 plus f of 1. And I'd ask you to take a moment now and just go into a calculator and compute those. That's going to be 1/12 times all this other stuff. And when we work this out, we get an approximate area of 0.94. 0.94. Just be very careful as you're computing each of those different pieces. That's going to be e to the 0, which would be e to the 1, minus 1, and so on. Sorry, I meant that'll be e to the 0 plus. Actually, I think I did make a mistake, so hang on a moment. Okay, just spot a little mistake I had made. I forgot to multiply each of those things by 2. In the middle terms, when I add them up, at 10.251, and when multiplied by 1/12, I get about 0.8542. And that's an approximation of that actual area. If you wanted a better approximation, we could do more trapezoids.